Okay. So if I'm solving this using elimination, my goal is to solve for my x and my y. I have to solve for one at a time, and then once I have one, I can plug it back in and solve for the other one. But for elimination, you have to line these up to where the y's match, the x's match, the equal sign matches, and then just the separate numbers by themselves match. So we are going to adjust these equations a little bit. I'm going to actually just rewrite this first one the exact same way next to it. So 5x minus 3y equals 3. And in this bottom equation, I'm going to rearrange it in a way that will allow my x's to be on the left-hand side of the equation, my y's to be here on the left-hand side, and then my separate numbers to be on the right-hand side of the equation. So to get my x on the other side, I need to subtract, or I need to add x on both sides. So I want to get rid of it on this side, add x, and it's going to move it over here. So we're going to have a positive x on this side. So when I rewrite it, I'm just going to put an x over here because I got rid of it on this side and I moved it over here. And then I want to move my other number, so like my 9, I want to move it to the right-hand side of the equation because we want it to match up with the 3, which is on the right-hand side of the equation. So I'm going to subtract 9 over here, and it becomes 9 like this. I honestly don't even really like to write them like over here. I probably shouldn't have done that because it just gets confusing. And then my negative 3y, I'm going to put it right here. It doesn't have to move. It's on the left-hand side of the equation here. It's on the left-hand side of that equal sign here as well. Okay. All right, and then here, my ultimate goal is to be able to combine like terms. So I'm going to put this equation bar right here. Uh-oh. This is, I borrowed this from a student last period and then didn't give it back. I have to take it to her. All right, I want to combine these like, or this equation. But what's going to happen? I really want to cancel out these y's because they're the same number. But if I add them together, then it's going to become negative 6. So does anybody have any idea, if you want to throw it out, if you feel comfortable talking, what I would do to be able to cancel out this negative 3y? Yeah, Gavin. Okay, yeah, that would be great. So if I multiplied one of these equations by negative 1, then what's going to happen is these can cancel out. So we're actually going to do that to the second equation. You can do it to the first one, but I choose the second one. And so you're really just changing the sign of each one of these. So if we multiply this first one by negative 1, it becomes negative x. We multiply 3y by negative 1, it becomes a positive 3y. Sorry, multiply the negative 3y. And then this becomes a negative 9. So you're really just changing the signs of each one of these. And now you can combine these like terms. So I'm going to put an addition symbol over here because we are going to add this 5x plus negative x. So it becomes a 4x. And then these cancel out so they completely disappear. You don't have to write anything. And then this becomes, I did something wrong. This was already a negative 9 over here. Yep. Yeah, you're right. So that was a mistake from earlier. I subtracted 9 on this side, so it should have been a negative 9 on this side. You guys see that? And so now I've got to go back and make it a positive 9. Sorry, that's kind of confusing. Because really all you're doing when you're putting these on the correct side of the equal sign is you're really just changing signs when you're putting it over here. So it was a positive 9 in this equation. It needed to be a negative 9 here. And then we multiplied that equation by a negative. So it becomes a positive 9. So 5 minus x becomes 4x. And then 3 plus 9 is 12. We're going to now we're just solving for x because the y is gone. So divide by 4, divide by 4. X equals 3. Okay, and then now it's up to you. You pick an equation that you want to plug this into. It doesn't really matter. I'm going to, why don't I just pick the first one? Or, yeah, it doesn't matter. 5 times 3 equals, or minus 3y. I should just not speak, that would be helpful. I need to write and then talk. So notice what I did. This is the exact same equation. This 5x minus 3y equals 3, and I just plugged the x in. So it becomes 15 minus 3y equals 3. And then there's the alarm for attendance. Don't let me forget to take it. Minus 15, negative 3y equals negative 12. I know I'm going quickly. And then divide by 3 on both sides, or divide by negative 3 on both sides. Y is going to be a positive 4. Okay, so I'll zoom this out a little bit so you guys can see it. Sometimes you'll see it written in this notation, 3, 4. Does anybody in here know why it's sometimes written in this notation? Yes, Enat, right? Okay. Yeah, so it's a point on the graph, right? Because you've got two lines. This is a line and that's a line. And what this is, do we know what it's called? It's, yes. You know. Yeah, it's where they intersect. Great. So that's why it's written like that sometimes. So like the x value and the y value. All right. That is elimination. Let's look at substitution real quick, and then that'll be it as far as notes for today, and so we'll be able to get into our stations. Okay, for substitution, which you can choose either one. So for number 2, you've got two equations. I am going to solve for y. I'm going to get y all by itself. And it's kind of up to you. You can choose the first one or the second one to get all by itself. I'm going to choose the second one. If you would like to do the first one, go for it. But I choose the second one. So I'm going to solve this one. Y, actually, no. I'm going to choose the first one. I don't know why I said that. I choose the first one. So I'm going to add y on both sides because that's just easier for my brain. So if I add y on both sides, I get y equals 3 minus 4x. Cool. And then I have this other equation over here, which I want to substitute in this 3 minus 4x. Is going to go in there for y.
Teachers, at this time, please take attendance for second period.
All right, let's plug it in. So we have 4 plus, so instead of writing y, I'm going to write this 3 minus 4x. You don't have to write it in different colors. I'm just trying to show you what we're plugging in. And that equals 3x. So I just plugged that in. We're going to now combine like terms. So 4 plus 3 is 7. Minus 4x equals 3x. Then we will add x, or 4x on both sides, because we want all the x's on one side, all the numbers on the other side. Add 4x, add 4x. So 7 equals 7x. Give me a second to write that. And then you want to divide by 7 on both sides, so it comes out to this easy 1. Okay, and then another thing I really like about substitution, I like elimination too. I mean, elimination a lot of times is easier. But if substitution is ever easier, it's because now all you have to do is plug that 1 in right there, and it's kind of done for you. Because this y equals 3 minus 4, and then we're just plugging in this 1 right here. So instead of writing x, I'm writing that 1. Okay, so I'm just taking this equation that I've already solved for and plugging that in. Y is going to equal negative 1. 3 minus 4. So we've got 1 and negative 1.